Now, today we want to learn about one very important statistical tool known as Cronbach alpha test. Now, I'm Daniel Makupi, and today I want us to see specifically what are the steps required for you to be able to undertake a very good Cronbach alpha test. So first, to begin with, Cronbach alpha test is one of the tests for validity and reliability of data collection instruments, or what we say tools, be that questionnaires, and for us to be able to collect data using such particular questionnaire, foremost we need to be able to calculate enough sample for us to be able to do Cronbach alpha tests. Now, straight to calculation of sample. So we have quite a number of ways in order to calculate enough sample for Cronbach test. So one particular is from Cronbach in 1979. He proposed about this Cronbach formula and this particular test, of course. And today, for this case, I want us to go through this particular formula by Bonnet in 2002, and he proposed that sample equals to 2k divided by k minus 1, of course, into brackets again, set scores, of course, set statistics. In other tutorials I've talked about set tables, and this is where we get values for the S statistic, divided by logarithm of null hypothesis divided by alternative hypothesis, so which actually I'm talking about taking into consideration. So for this case, for us to be able to employ that particular formula, I have my test data, and in this case, in my data collection tool, I have 36 raters. When I say 36 raters, it means that I have 36 questions. So for me to be able to use that formula, alpha 0.05, beta 0.1, in this case null and alternative hypothesis chi 36. So taking 1 minus null hypothesis, alternative hypothesis, divide by 1 minus null hypothesis gives you 3.333. So you do a square of logarithm of this particular. So anyway, putting my 36 key raters multiplied by 2, and then the sets from the set tables, I get the value for 0.025, which is 1.96. For 0.1, at 0.1 you get 1.282. Then you square and then you add 2. So anyway, for us, I wanted us to appreciate that we have steps in order to calculate the sample size of enough sample size for Cronbach alpha test. So in this case, I got for my study, I get 16.9, which is approximately 17 samples for us to be able to compute Cronbach alpha. Now, straight to that, I want us to go to my test data. So I have my test data here in my drive. Here I have a tool I'm collecting data with. So I want us to take note that when you are calculating Cronbach alpha test, you can use Python, you can use Excel, you can use SPSS. But for this case, I have an online form. I administered this questionnaire online, and then of course receiving my responses. In this case, for this particular sample test, I have 14 responses. So I'll click that one so that I can get it in Excel format. So once I get in Excel format, you can see here are my data. So going straight, I want us to pick this data. So I will first need to download, expecting it in Microsoft Excel. So Okay. So we waited to download for a few seconds so that we can have the test data to be able to run this Cronbach alpha. Okay. Super. So we have our test data here. So the first thing I need to do is I pick these numeric variables, and remember, when you are computing Cronbach alpha test, you only use numeric data. So what we should say, ordinal data. So, okay, I pick this data. Okay. Pick this data. I open a new worksheet. This is my data. Now let us calculate Cronbach alpha. So if you have Excel, there's this data tab and also data analysis. In my previous video, I have talked about the steps required for you to be able to install data analysis toolbar. It is not automatically inbuilt within the Excel. So you need to download and install. There are steps of doing that. So I click data analysis. Within the data analysis toolbar, you have a number of analysis that you can run, but specifically we are interested in Cronbach alpha, and for that reason we choose another two-factor without replication. So then of course you pick the first to the last row, this other side. All the rows are employed for this particular test. Control yes. No, ANOVA two-factor without replication input range contains non-numeric data. Normally, this is as a result of maybe some of the respondents might not have filled the form or the spaces, so it's assumed that there is some data which is not numerical. For that case, we just put in the empty. We replace empty with maybe 1 in that case. So replace all. So you could see there is one replacement being made. It means that someone might have missed field 1, which is still okay. So from there, we go back to our data analysis toolbar. Okay. Okay. Super. So this is where we get our two-factor without replication. So here we get the rows and column, all the rows and all the columns. But our interest goes to down here. You get ANOVA. And in this particular ANOVA, I want us to take note of this particular ANOVA table. Within this ANOVA table, I want us to do some small computations, equal sign. So for us to calculate, for us to be able to calculate Cronbach alpha, 1, we take equal sign. For us to do any computation in Excel, equal sign 1 minus parenthesis mean square error divided by mean square rows, then you close parenthesis, equal, then press enter. You get 0.98. So this is our Cronbach alpha. Thank you. Yeah. Can you be able to do? Just take some few minutes, practice and practice again. Thank you. Like my videos. Have a good time.